So basically, we discuss about the energy flow diagram. There are multiple process, but we only need to know about this process. I already told you the reason, because nuclear is completely included. It also have its own chapter. So that's why they only give you the energy flow diagram in detail for this topic. There are different way to generate electricity, or to generate convert one energy into the other with different mechanisms, but this topic is important, and you only need to know about the name of the energy, conversions of the energy, that if we are using nuclear reactors, so what type of energy we are getting from that, if we are using a steam generator, so what type of source of energy in that, then turbine, then generator, right? And that is very simple. Okay, so till now we studied about the concept of work and the energy and the energy flow diagram, and you already know about the concept of law of conservation of energy, right? And let's suppose, before starting the concept of the power, if we consider a question like this: if there is a toy car, let's suppose if we consider one toy car, and that toy car has to move through this path, and if we mark a different random positions, point A, point B, point C, and point D, because you know that B is on the right hand side, it's just like a motion of a roller coaster. So when this toy car starts to move from the top position, so it will first move through point A, then point B, C, and D. So basically, they will ask the question in the different form, that to know about different conversions of energy at different points. So let's suppose if we start talking about point number A, so you have to answer that how energy is going to take place, or what is the change of energy take place actually at point A. So if we start from the top point, so at the maximum height, or at the, yes,
The gravitational potential energy changes into kinetic
yes.
energy.
So basically, we studied about the concept of potential energy. So at maximum height, we are having maximum potential energy.
So like basically wouldn't it be like potential gravitational energy or something?
Yes, gravitational potential energy, or just simple potential energy. So initially we are having potential energy, and when the car starts to move from the maximum height to point A, so actually your gravitational potential energy converts into which type of energy?
Kinetic.
Kinetic. Clear, everyone?
Yeah.
So can you repeat just once? Sorry.
Basically, uh, just like if we take the example of a ball, like free fall motion, when we just drop the ball from the height, or when we just release the ball from the height, so initially when the ball is at certain height, so you know that due to gravity, energy is stored in the body, right? And that energy is known as gravitational potential energy.
Potential
Basically,
energy.
that is
Yeah.
potential energy, but it is due to the gravitational force. So that's why we write gravitational potential energy. And that's why at initial point, I just write the name of energy, that initially we are having potential energy maximum. Completely there is potential energy. And when we just reach that point A, so at point A, you know that that toy car starts to move. So when body starts to move, so you know that the energy due to the motion of a body is known as kinetic energy. So basically at point A, your gravitational potential energy starts to convert into the kinetic energy, right? It is not completely convert into the kinetic. Still, it has some potential because it is at certain height right now. But at point A, your gravitational potential energy simply converts into kinetic energy, right? And next, if we talk about point B, so what do you see that at point B, what type of energy or conversion of energy takes place? Because you know that just like the white line, it is just like a roller coaster. When it pass through point A, then again it will move in the upward direction. In the upward direction, it is going in upward direction. So what do you think that at point B, what type of energy is stored in the car, or what
Potential energy.
potential energy, or what type of energy change take place over here? Because initially when we are moving on the track, so we are having kinetic energy, and when we starts to move against the gravity, just like when we throw the ball in upward direction, so when we are moving against the gravity, so again potential energy is stored in the body. So it means that your kinetic energy again converts into potential energy. Clear? And when this car just take round on the circular track and it comes to point C, so at point C now car is moving in downward direction. So again what happens, your gravitational potential energy again converts into kinetic energy, right? Because now we are moving in downward direction, so your energy will convert into the opposite form, that is from gravitational potential energy to the kinetic. So we can say that into the kinetic energy. And finally, what happens at point D? Any idea?
Could you repeat the question?
When did we
Now,
stop it? It would stop.
you know that point D is very far away from the circular track. So when a car just take the turn from point C and then it starts to move into the direction of D, so what type of energy is now at point D in the body? So now the car or the roller coaster only has kinetic energy, right? Because now car is moving on a horizontal track. This track will continue in a straight line. So now car is on a ground level and it will starts to move only in a single direction. So you know that the energy due to the motion of a body is known as kinetic energy. So at point D, we are only having kinetic energy, right?
Yes.
Because now we are not moving in upward direction, in downward direction, so there is no change of potential energy. Now we only have kinetic energy, because at maximum point we are having potential energy maximum, and on the ground level our kinetic energy will be maximum. Okay. And one more thing that we missed in every part, because in the question it is not compulsory they will ask every time, but you know that if we want to write another form of energy that actually converts during this process, so that type of energy is thermal energy, right? Because during whole process, again the concept of efficiency, that nothing is 100% efficient, so there will always a thermal energy included everywhere.
Wait, so I have a question.
Yes.
So if I suppose this cart was standing stationary at like a very high point, its
Hmm.
gravitational potential energy will be max, right?
Maximum, right?
Okay, okay. I'm just asking.
Just like if you just holding at certain height, so you know that due to the position potential energy is there, but when it starts to move, so actually your energy is going to be converting, right? And thermal is always there, because you know due to friction, due to air resistance, So thermal energy will always there. But our main concern is to know about the type of energy that actually converts over there, because thermal energy is just like the complementary type of energy everywhere because of friction, because of resistance, right? So in simple words, we can say that the total energy we provided to the system, like if we take the concept of total energy, so initially we have some amount of energy, like at the maximum point we are having maximum potential energy. So that energy converts into useful energy, because our purpose of using that cart is to convert potential energy into the kinetic energy. But still, due to the concept of thermal energy, there will always a concept of wasted energy. Basically wasted energy in the sense that thermal energy is not
Heat
required in
energy.
this whole process. Yes, just like to make the roller coaster more smooth, more efficient, we use ball bearings, we use oil to reduce the friction. So the thermal energy is not our priority, so that's why we use the word wasted energy, but still that is also a type of energy, right? Just like your engine got heat up, so basically our purpose is not to heat up the engine, right? But we know that not all form of energy convert into single form, it will also convert into some other form also. So that's why we use the concept of wasted energy. Okay, clear? Any confusion? Basically, this chapter is very much simple because it is related to the daily life example, and you just need to relate the type of energy with your example. Then it is very easy and very basic concept. So this is the concept of conservation of energy plus the energy flow diagram. Okay, any confusion? Okay. And we are talking about the efficiency also, so we will also discuss that efficiency formula because that is also included, the calculation is included. But before that, we just start the final concept of this chapter, which is known as the power. Initially we discussed that in simple words we can say that energy is the ability to do work, right? Ability to do work, in simple words we can say that it is known as energy. And for power, if we want to write the concept of power, so we use the word powerful engine, powerful vehicle, powerful machine. So basically the word of that power is, now we are going to compare that work done with respect to time. Okay, so whenever you try to compare your quantity or want to divide that quantity with respect to time, so that is the concept of some new quantity. And now if we want to compare our work done with the time, so that quantity is known as power. So in simple words we can say that rate of doing work is known as power. Okay, just like if you are writing a one page in 10 minutes, right, and I'm writing that same content, that same one page in 20 minutes, so you can say that your work done is in less time and I will do the same work in the time interval greater than your time. Okay, so the in simple words we can say that the power of the writing or just completing that page is different for both persons. Just like we use water pumps or water motor to just fill up the container or the water container, so there are different motors with different powers, right? So actually that if the motor has greater power, so it will take less time to fill the container, and if the power of motor is very low, so it will take more time to fill that same container. Okay, So rate of doing work is known as power. And again, you know the formula that we have to divide the concept with time. Power is equals to W over T. If we are taking the example of normal car and we compare that car with the racing car, so you know that the power of racing car is greater than the normal car, because we know that the speed
Let's I have a question.
yes,
What's the formula for work done? Is it just like the same formula for kinetic energy or
yes. Basically
gravitational
for the work
potential?
done,
Force
uh,
direction.
this is the formula for work done, F into D,
Oh yeah, right,
into
exactly. Yeah,
displacement, right?
I was trying to remember that. Okay.
Yes. So you can also write this formula in the form like this, because work done is known as F into D. So it depends upon the question, because sometimes you know quantities are not given directly. So we can use the indirect formula FD over T, or in simple words, you can also say that your power is actually rate of change of energy also, right? So basically, we discussed that the concept of work and concept of energy both are having same units and same concepts. So that's why we can also use the same rate of change of energy concept in this formula, right? Any confusion? And the second main thing is the SI unit for power. So what will be the SI unit for power? Any idea?
Power is
What? Wouldn't it be what?
Yes.
that's in
Yeah, it's
wait,
watts.
really? Oh, I didn't. Okay.
Yeah.
So basically, if you remember when we are using that orange bulb, so there is power given on that bulb like 60 watt, 100 watt. So actually that watt is the SI unit of power, right? So when someone asks you about the SI unit of the power, so the SI unit of power is watt, and that gives you the concept of the SI unit of the power. Okay. And formula is very simple, and you can easily use this formula anywhere in the numerical questions in different situations also, because you can also, if force, displacement, time is given, so you can also find out the power with the help of FD over T formula. And if direct work done is given, so you can use P is equals to W over T. And if they are asking to find out the work done, power and time is given, so just multiply the time on the left hand side, just shuffle the equation. So this is the concept, right? And the next thing that we have to write is the concept of efficiency that we were talking about from the start, that nothing is 100% efficient, so there will also a lose of energy sometime. Basically this chapter is lengthy in the sense because it also contains the conceptual questions plus the numerical questions, because there are multiple formula in this chapter plus there are multiple concepts in this chapter. So that's why they will more ask about. And it is also like we discuss about the forces, we discuss about the motion from the start of journal physics. So energy is related, or energy is included in each and every topic. You can identify the type of energy in each chapter, in each example, right? So that's why this topic is very like the basic or the common. So if we talk about the efficiency, so efficiency can be calculated just like you calculate your percentage in any paper. So you write your obtained marks in numerator divided by the total marks in denominator, multiply by 100, right? So that is the efficiency basically. So we have to write the same thing, that the useful energy output or useful power output if energy is given in your question, so you can write the formula in the form of energy. And if power is given in your question, so you can write that formula in the form of power, right? So useful energy or power output divided by the total energy input. Just like the process we already discussed, that potential energy is the total energy, then it converts into kinetic plus thermal. So that thermal is the form of energy, kinetic is the useful, multiply by it to convert into the percentage, right? Because you know that the value in the numerator is smaller than the value in denominator, because we have to calculate the efficiency, so your percentage will be less than 100, because again, nothing is 100% efficient in our case. So that's why your value will always less than 100%. That's why in every product they used to write 99.99%, because they also know the law of conservation of energy, that we are not able to generate 100% efficient result in any situation, right? And again, you know that both are the comparison of same values, so there will be no SI unit. Okay, for efficiency it is only a number that will show you the ratio of two quantities of the two values. Like if you are writing your percentage like 96%, 98%, so it means that you just cover that content in your paper 96%. 4% is not correct, or you are not able to attempt that 4% of your paper. So that is the percentage or the concept of efficiency in your exam also, right? Clear? Any confusion?
No, sir.